Hi guys, today I'm gonna present you the project 1 and project 2 of Nand2tetris, and I'm doing this as a digital assignment for my professor Dr. Abdul Kader, and I really thanks her for giving me this opportunity. So today we'll be working on project 1 and project 2. The project 1 consists of in project 1 we'll be using NAND gate to implement different other chips or gates as you want to say. So in elementary chips we have the NOT, AND, OR, XOR, MUX, DMUX. Then we have the 16-bit variants, NOT for 16 bits, AND for 16 bits, OR for 16 bits, MUX for 16 bits. And then there are multi-way variant like more than like many bits. So it's OR for 8-way, and then mux for 4-way with 16-bit, mux for 8-way for 16-bit, dmux for 4-way, and then dmux for 8-way. And then we have the project 2, in which we'll be making a full adder, half adder, add 16, ink 16, and an ALU. So let's begin with it. So basically, guys, we have this website nand2tetris.org, and this is the website from where we have to download the software on which we'll be working. So these guys have developed a software in which we can run different chips or the gates. We can run it on our laptops as a program. So we don't actually need those gates physically. So from here we'll download. We'll go to the software link. I've already downloaded it, but to show you guys. So this is from where we'll download, and these are the guidelines for Mac users and Windows users. We are working on a Windows user right now, so hope it's easy for you guys to download. And then if you want other project descriptions, you can get it here for project 1 and project 2. Similarly, they have different projects, but we are working on project 1 and project 2 right now. So let's see it now. So guys, we have opened the hardware simulator which we had downloaded. Like it's in the tools part, tools folder of the downloaded thing, and then you can open it. You will need a JRE in your laptop. If you don't have it, you can download it from anywhere. It's written in the project description too. So after you have downloaded everything, just open the hardware simulator. So this is my first time working on this too, but I've tried it once just before making this video. So let's hope that I'll be able to explain everything to you. So this is actually how it looks, and then we click on this button and then we can select the chips that we want to run. Chips are mainly written in HDL files, so these files are kind of a command for how a chip works. It's all logical thing, and then we can run it as scripts too, but right now we are going with the chip thing, and then I'll explain you how we can run it from the chip script. So we select from where we have to take the thing, and then okay, so yeah, so this is the DA one. So we open this, and then we have all the chips here as we want. And so I've run, so I'm finding it little bit easy now. So now we'll start with AND gate. So let's see. So guys, remember that in this we are working with gates that we have built from NAND gates. NAND gates are our basic gates from which we have built different other gates, and now we'll be seeing the implementation. So we select this and then open it, and then we select this file and.htl. So you see I have many other files in that, but they are showing only HDL files because HDL files are the one that are the actual chips. So let's load this, and then we see that yeah, so it's here. So so basically what does a AND gate do? So AND gate basically takes two input data and then gives us the output as like if we have 1 and 1, then we'll get an output of 1. So it basically is a logic gate. So let's see how it works. So if I have a as 0 0, then the output is 0. So when I will have I'll make a as 1. So in AND gate, if both the values are true, taking that 1 is true and 0 is false, then if both the values are true, then only we'll get a true output. If one is false, either one is false, then we'll get a false value. That's 0. So let's see if it works like that or not. So we have input a as 1 and then we run it. So we enter and then we run it. It's again the output is 0. So let's make this 1 now. So now we have both values as 1. The output should be 1. Let's see. Yeah. So our output has changed to 1. So this is how this works basically. And now for the like we can we were right now entering in some other format now, so we can select format from here, decimal, hexa, binary. This will come in use later when we implement other gates. So this is a basic gate right now, so it's simple. You can see the script. This is something computer has built. We can also write our own scripts. This is for output, compare, and screen. So yeah. Now, so we have implemented AND gate. Now let's see if we can implement AND gate with a script file. Okay. So first we go here, and then no, right now we will implement another gate which we have in a file. So now we are gonna implement AND gate of a 16-bit version. Okay. So that means the input will be in 16-bit form. So let's do it. Let's write 69. Okay. So enter, and then we go the output because one is false. So let's make this also 69. Enter. Yeah. So you see whatever the value is, I've input it, and then the output has come in a positive manner. So as we were working with this AND 16 gate. So it's a AND gate for which we can input the values of 16 bits. Before we were giving only 1 bit value, 0 and 1. So this is a 16 bit value. So right now, as we can put we have selected decimal format, we can write a decimal number 69. So we'll write 69 and then enter. We write 69 and then enter. Okay, what's the problem here? Let's see. It's not taking the input. It's going to 0. Actually, there's some problem with this. So okay, so just let's load the script right now. Okay, so we have the TSC. That's a test that we are loading. So the script is loaded here. As you can see, the inputs are in 16-bit format. And so the comparison or the AND gate will be done between two inputs that are in 16-bit. So this is it, and then we can run it, and this will show how the program moves from one step to another. This way it goes, and the value keeps on changing. As you can see, the value keeps on changing. So we can see the output too from here. So this is the output, and like when a is 0, then the output is 0, and then that way we can do it. So on the value changing, the output is shown here. This is actually a truth table. So it's done like this. Now as we have completed this, now let's move on to the next one. So we'll be going for, let's see what's next. Now we'll be working with demux. Okay, actually no, let's go for a much easier one. Let's go for the OR gate now. After AND gate, let's go for OR gate. So let's do this. First we are loading the chip as you should remember, we are loading the chip right now. Chip is in the HDL format and a script is in TST format. Okay, so right now we have loaded the chip and we say run. Okay, so the output is 0. So right now we are running OR. That means if even one value is true, it will give us output as true. So we had 1 and 0, so it gave 1. Let's make this 1. So this will, what will it give? What will this give? 1 and 1, it will also give 1 only. So let's see this, and then after that, let's see if we put 0 0, should it give 0? Yes, it should. And let's see if it gives it or not. So we have output as 0. Okay, so now as we have done this, we have input the value and seen it. Now let's load the script. So how do you load the script? We go here and then or.tst load script. So the script is here. Now as you can see, the values, they have given all the possible values. As this is a single bit operator right now, so it takes single bit, so 0 0 0 1 1 0 1 1. So this is it, and then we can see it in our output format also. So this is the output. This is basically your truth table being formed. As you remember, you might have studied the truth tables for OR gate. So this is actually the truth table. When both the values are 0, output is 0. When one is 0 and one is 1, then it's 1. So this way it's done, and then we move on to next. Next we'll be doing OR gate for 16-bit, just like we did AND gate for 16-bit. So we move on and OR gate for 16-bit. Yes. So we select this. This is the chip, load chip, and then so OR 16-bit. Let's see, 69. Now it should show 69. Let's see. Yeah. So this is right. And then if we make both has 69, it should again show 69. Okay. Yeah. So it's again 69. Now let's see. Let's load the script and see how it works actually. So load script. Yeah. So all 16. This is the script. So we have again 16-bit inputs and then the output is given. Now let's see the truth table that is being formed. So let's go. Okay, so the truth table, as you see now, they are showing the 16-bit values of the same thing. Yeah. So that's actually the range. The things you're seeing in negative is the range, the 16-bit range that is followed. Okay, so this is done, and then we move on to next gate. That is, so as you see in this, this is the HDL code which we have written. This is actually a code which we have to write for this to work, for the chip to work, and this is described in a different way. So like for 16-bit we are given the array kind of thing, so it works like that, 0 to 15. It stores every bit as we know. So after that we have, now we have to work on, we have done AND, we have done AND 16, we have done OR, we have done OR 16. Now let's work with, okay, what should we work on? Let's work with NOT. It's the easiest of all the gates. So what does a NOT gate do? Oh, I think so I have not selected. Yeah, NOT. So what does a NOT gate do? NOT gate just negates whatever the input is. If the input is 1, that's true, then it makes it false, that's 0. If the input is 0, then it makes it 1. That's for a single bit. So yeah, we are gonna see the single bit thing here right now. So let's see it. So the input is 0, as you can see it's already written. So make it 1 and then see what happens. Run. And the output is 0. So stop it. Let's see the script now. So this is the script for it. Load the script, and this is the script. So we have two values, that's two possible values, that's 0 and 1. So let's see the output. That's the truth table actually. And so this is the truth table. When input is 0, the output is 1. When input is 1, the output is 0. So that's it for not. And then we move on to the next one. So the next one is, so okay, we have done not. Now layer, let's do the not 16 version, like 16-bit version. Okay, so we have here now. So we are inputting the value in negative, sorry, decimal. So let's put 69. Okay, and then run. So that's the output, minus 70. Okay, so now let's see the truth table. Okay, so we load the script first, and then after loading the script, you see the input says 0 0 0 1 1 1. So that's the max value, that's the min value, and so these are middle values. So let's see the output. That's actually the truth table. So let's go play, and the output is being formed. Negation. So if you exactly know how the binary, how the 16-bit negation works, so you'll understand this. I don't exactly get it, but somehow I understand that it's being negated. So yeah. Okay, so if you turn it in hexa, then 1 2 3 4 gives the output EDCB. So that's something that I don't understand very well. So let's go now to the next one. Now we'll be moving on to, we have done, and this is done. So let's move on to, so let me see first. We have completed not, we have completed and or. Let's complete XOR. So we'll do the XOR gate now. What is XOR gate? So XOR gate is basically exclusive OR gate. That means it will give a true value only if, let's change this to decimal now. It will give true value only if single one of them is true. If both are true, it will again give a negative false value. So let's see. So single one, and then let's run it. Output should be 1. But if we give both of them as 1, that's both of them is true. So what will happen? Let's see. So it's giving us 0. Yeah, okay. So this area also shows our internal pins, how it's working. So this is how it's working. And now we are gonna do this. Now let's load the script. Okay. We are loading the script for XOR, and this is the script. So all the possible values, and this will be the output. Let's run it. That's the truth table now. So yeah. So as you can see, when it's both one or the same values, then it's 0 for 0 0 0, for 1 1 0. So I hope you understand this, and then we move on to the next one. So we have completed not and or XOR and not 16-bit and 16-bit and or 16-bit. Now let's do the mux. I think so. Let's do the mux. That's the most easiest one and the left ones. So yeah, we move on to mux. Yeah, so what is a mux actually? What do you understand by a mux? So what a mux does is it inputs two values. That is, actually it inputs three values. Two of them are data and one is a select option. So mux is kind of a selector for you. It takes in two values and gives out a single value depending on what the select option has. If you have two values, let's take A and B as you can see it here, and you have a select option. So in select option, you have to specify which value you want to output, the value A or the value B. So that's done. So let's see how it works. Let's give a value 1 in A and let's keep the V value 0. And when the select is 0, let's see what will be our output. Okay. So we have the output as 1. That means whenever select is 0, we'll have the output of A, whatever stored in A. Okay. And then let's see if we store 69. Can we store 69? I guess it's no, we can't because it's a single bit thing, so we can just store 0 and 1. Okay, so we move on to, okay, let's change this to hexa. Okay, so 001, the output is 001. Similarly, we can change to binary, which will be same. And so let's do, yeah, okay, let's work on if we have b at 0. Okay, let's keep the same. We change the select option. Now we want to display the b option, so we have 1. This will give us output as 0. That's b actually. So let's see the script how it works. So this is the script, and now we'll go for the output. That's the truth table actually, as I have told you many times. So let's see. Whenever A and B is 0, select anything, it will give 0 because both have the same values. When A is 0, B is 1, select 0, it will give the first out. That means 0. And similarly, when it's 1 and then it gives 0. So that's how it's done. So let's see if we can edit the script and work something around. Okay, so we have 0 0 when selected 0 1. So let's see we can edit the script or not. No, we can't. We'll have to change it there. So you don't have the edit option here. You can edit the script anywhere in Notepad++ or any editor you are using. So basically, if you want to check it if it's working or not, you want to check it yourself. So just put A as 1, B as 1, and select anyone. It will show 1 only. Or just as we have seen here, that 0 and 1 option. So just exchange the A and B values. Give A as 1 and B as 0 as we had done before. So after this, we'll go for, we have completed mux. Now let's go for demux. Or should we do mux 16-bit? Let's do mux 16-bit because that's what we are following. That's the pattern we are going in. So let's go for mux 16-bit. So now we can input the 69 thing we were talking about. So let's go. Let's put 69 here and let's put 49 here. So now you will exactly get the point now because two different numbers 0 and 1 you are not that clear. Okay, so now 69 40. If I'm giving select as 0, it should give me the A option. So let's go. Yeah, so I got 69. Now if I want 49, so I'll get 1 and then run. My output is 49. So let's see the output. Let's run it. Okay, we'll have to load the script first. So mux 16, let's load this thing and then we go for the output and we say play. So the outputs are given. Similar thing, just that it's a 16-bit code now. So as you can see, it's 16-bit, not a single bit. So that's how it works. Similar to mux, just the bit changes. So now let's do demux. For Dmax, we'll be doing only a single bit because I hope you will get 16 bit too without me explaining it to you. So let's do it. So we'll be doing Dmax now. So yeah, we have the Dmux now. So what is a Dmux? Dmux is actually the inverse of Mux, as you can see, Mux Dmux. So it's kind of in the word. So what actually Dmux does is it takes a single value now. So it takes a single value and gives you two outputs. That depending on the select again. So let's see if I have the value as 0 and the select is 1, what will it give? So both the values are 0. If I give the value as 0 1 or 1 0, it can't because it's a single bit right now. So let's give it as 1 and then see again. Put the value. A is 0 and B is, so let's understand this better with the truth table right now. So we'll go to the truth table. How we go to it? Let's load the script and all the possible values, that's 0 1 1 and then okay. So just let's load the output, okay, and then play. So this is the output, this is the truth table. So see, we have the input as 0, then we select 0, then we get both as 0 0. So in 0 whatever we select, we'll get both the outputs as 0 0. And so actually how demux is used is you give two options within, like and operation and or operation, and you give two values a and b. I want, if I wanna do and operation with a and b, then we'll select something so that my and operation is done. If I want to do my or operation, then I'll select the opposite thing in the select option. So that's how it's worked, and this is the logical thing just. So I hope you get this. Then we move on to the next one. Let's load a new chip. Next we'll be going, yeah, so all the elementary and 16 bit are over. Now we'll be moving to multi-way. So this is the real thing, and so let's see. Yeah, so moving on to multi-way, we have OR 8-way first. So in OR 8-way, what we have is a 8-bit input which will give a single bit output. So let's see, let's give a number. We have selected decimal and then play. So you can see here the internal pins that are there, and then the output is given here. These all are put into or inputs, and then the output is given. You can see different kind of outputs or the truth table. Actually I can show it to you. So first let's load the script or 8-way. So this is the script, as you can see it's a 8-bit code, and then let's see the output. Okay, here this is the truth table. So last number is 38, and then you can, as you can see, the internal pins are here. Okay, so AB gives C, and AB only gives D, and AB only gives E, and AB only gives F, and then AB gives G, and AB gives H. After what? G and H are given from what? Taking C and E in. C and E combining. And then E and F you combine and you get H. So first two inputs are taken, the first one and second one. From that we get C and D. After that the next two is taken, and then we get, similarly we get different values. So you can see here 0 to 7 it's done. We get 4 values from 8 bits of the number we have input, and then after that from those we combine 2 bits like, and then use that for 2 more outputs, and those outputs are then giving us one single output finally. So this is it, and then we have our multiplexer 4-way 16 bits. Okay, so multiplexer 4-way 16 bits. Load. So now what we are doing is we are giving 4 inputs. We are giving 4 inputs manually, and those inputs are of 16 bits, and we give a select option. Now what is happening is, you know what Mux does, it takes multiple inputs and give you a single output. So in this we have a select, but in this you can see as the inputs are of 16 bits instead of single bit. So select has become of 2 bit because we have 4 options now. Before we had only one option, so we could give 0 or 1. Now we have 4 options, so we have to give 0 0, 0 1, 1 0, 1 1. So it's that way. So let's see. First input we will give 16. Okay. And then we'll take 45. Then we take, let's say, 69. Next we have 33. Now if I want any one of them to view, so let's say we have to show 69, so it will be 0 0 0 1 and 1 0 we have to print. So we'll give the select value as 1 0. Okay, it's not taking, let's say 1 0. Okay, that run. Okay, so it showed the 0 value actually. It should show. Okay, let's give 1 and see if it shows 45. Okay, it's not. Let's say 1, enter. Okay, let's see. Yeah, I don't know why it's not taking. Let's try again. 0. Okay, it's a decimal value. So this is the first number, 0th number, first number. Now let's see if I'll put 2, then it will work. Yeah, okay. So 2. Because it's a decimal number. So we'll get 69. That's fine. If we put this to binary, then these all change to binary, you see. Okay, so we are viewing it in that decimal right now. So now let's load the script now. Okay, so Mux 16. So this is the script. As you can see, 4 16-bit values, and then we take this and all the function it's given. Then we give the output and we say run. As you will see the truth table. So 16 bit, 16 bit, 16 bit, and it's not going that side. Let's try again. We can't extend this. It's not going that way, but if we go that side, it's the output that's being shown. I don't know why it's causing some problem, but okay, I've shown you here, so no need to worry. So we are done with this also now. Now we have the next gate we are gonna do is mux. Now we'll have 8-way with 16 bits. Okay, so 8-way 16 bits. We did right now 4-way 16 bits. Now we'll have 8 options. So you have option from 8 inputs what you want to see. So just let's put 13, 14, 16, okay, 15. So we'll put all the numbers in a row. Okay, and this will be okay. So this is how we have done. Now if you want the first one. So we'll put 0. Okay, we'll keep it 0 and then run. So we got 12. Now put it as 1. So we get 13. So how does this actually work? So what we do is we have these all inputs and then you can see it here. What we are writing is in here is, so I've got some problem with this my thing. It doesn't go the sideways. So okay, we can select. Then you can see mark 16 you have taken first. Okay, so A and B inputs, 12 and 13 goes inside, and select is what? 1. So we select output is Q, that's 13. Then similarly we do this here. What's here? What's here? Okay, so 14 and 15. Yani next two outputs, 14 and 15. Then again select is 1, and then this goes in. So that way we have done, and then we have segregated it, and then finally we work with the outputs we get. Okay, so final output comes out here. Okay, so that way we work. And so moving on to the next one, now we have a four-way demux. Now we have a four-way demux. So let's do that. Demux four-way. Yeah. So open. We go to load chip and then a four-way demux. What is the demux? You give one input and it gives you four outputs. But you have to select where the main output goes. So it's like this. We give you 1 and select, I guess, 2. Okay, because it's in decimal, or we would have written instead of 2, that's 1 0. So we play, we get it at 0 1 2. The 1 is gone at the C port. Okay, similarly if we give this as 0, all of this will become, what will it become? 0. Get it? Yeah, okay. So let's load the script now. I will show you the truth table. So we go, and here is the truth table. For zeros, all are 0. For ones, where the 1 will go, you have to see. It goes in first, it goes in second, it goes in third, it goes in fourth. So that's how. Next, we'll be doing demux 8 way. Now we'll have 8 options. Okay, so I've selected the old one only. Let's go to the new one. Demux 8 way. Okay, it's here. Yeah. So we go there, and that's here now. So let's import, I guess we input 1, and where do we want to see it? Let's say we want to see it at 8th position, and now let's do it in binary ones. So if we want to say, we have to put it here, 8th position. So what will we do? Now it's a 3-bit select. So this will be 0 0 0. This will be 0 0 1. This will be 0 1 0, and this will be 1 0 0. So this will be 1 0 1. This will be 1 1 0, and then this will be, okay. So let's do it in decimal only, for it will be easier for you. And so we go from here and say we want the 8th up. That means 7. So run. You'll get, okay. So 0 1 2 3 4 5 6 7. Okay, let's see what the problem is here. Let's load the script and see the truth table. Actually, I think so I have written something wrong. Let's go. we input 1. Where is 1? Okay, it will show. So as I told you, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So we had to write 1 1 1. Then it would have shown here. Okay, so let's see. If we write 1 and 1 1 1 1. So, zero. Okay, so this is the script running again. I had to quit it and then work it. Okay, so let's move on to next. I hope you understood this. Okay, so there is nothing more in the project one. We have completed it. So let's move on to the next project, and we have full adder and half adder in that. So we'll be going to that, and then we have the full adder here. Okay, full adder. Now we have the full adder. As you all know, what a full adder does is it adds two values and gives a carry also with that. If I add 1 and 1, then there will obviously be a carry. So let's see. If I add 0 0, it will give me. So when I add 0 0, it will give me 0 only because some of zeros are 0. So as you can see. Then if I add 1 and 0, then I'll get. What do I get? I get sum as 1, carry as 0 because 1 plus 0 is 1. And then if I do again, if I put 1 in B and 0 in A, it will be the same. Then I'm putting 1 in both. So now you will see some change in carry. Yeah. So 1 plus 1 becomes 0, but the carry goes to 1. That's how this thing works. This is the full adder, guys. Yeah. So let's see the script now. Let's load the script and let's see the output. That's your truth table. Yeah, as I told you. Okay, so we were working with three things now. So I showed you the two problems and we have three inputs right now. So three single bit inputs. So as you can see, it works out the same way. If it's 1 1 1, I can show you again if you want, but I guess you will understand from this. Yeah, okay. So let's move on to half adder. So this is the half adder, guys. Half adder, what it does is doesn't actually gives much of a carry. So we take one here, same thing. It adds two values. Now let's see what the difference is. So we go next. Same thing, but it's in a half adder manner. So this is how it works. It gives you sum and carry. So I hope you understand this. Thank you for watching this video, guys. I hope you like it and understand the two projects. I would also again like to thank my teacher, my professor, Ms. Dr. Abdul Qadir. Thank you so much.